All right, let's do a second example here. I had to break for office hours there, so we'll pick up where we left off. We were talking about concavity here, so we're going to, according to the instructions here at the top of this page, use the concavity test to determine the concavity of this function. So to do that, first of all, dy dx, we need to get to the second derivative, and we can't shortcut that unless we do the first derivative first. So this gives us a 2/5 x to the negative 4/5, and then d squared y dx squared would give us a negative 8/25 x to the negative 9/5. Okay. And so our concavity change is first of all going to happen any place that we have, we're going to look for them at critical points of the derivative, which are any place that this is either 0 or undefined. Down here, this is, you could write it as a negative 8 over 25 times the 5th root of x to the 9th. So clearly 0 is a problem here. There's nothing that's going to make this equal to 0. So my critical point is happening at x equals 0. The original function, the 0 works just fine. So the point 0, 3 is on the original function. And if we want to know if this is a point of inflection, if where the concavity is positive and negative, it potentially changes there. If I do put negative numbers in for x here, I'm going to get a negative number out, and then the negative 8 divided by a negative number in the bottom is going to be a positive number. So if I thought about my axis here, my concavity, the second derivative over here is positive, which means that this function is concave up to the left of 0. And if I put a positive number in, the denominator all comes up positive, and the negative in the top means that my second derivative is going to be less than 0 here, and that is going to be concave down at that point. Again, shaped like this here and shaped like this over here. And in fact, if we took a look at what this function looks like, I might even be able to have this just generate a graph for me. I have to change the properties on that because it's not showing enough of it. My x's, I'm going to start a little smaller x and go to a little bit bigger x, but mostly I need to end at a higher value up this way. And I'm a little bit surprised that I'm not seeing more graph off to the left here. That's that one. It should have also come down through here and kicked off out this direction. That's what 2x to the 1/5 plus 3 looks like, and we can see the concave up happening here. And then it switches right at this point and becomes concave down after that. Okay. That sadly is something we don't get to do. So points of inflection. What is a point of inflection? By definition, a point where the graph of a function has a tangent line. So we first of all have to have a tangent line there, which means there is no corner, there's no cusp, there's no discontinuity. Okay, and where the concavity changes is a point that we're going to call the point of inflection. Okay, so if we wanted to find potential points of inflection on y equals e to the negative x squared, it's about concavity, so we're going to have to do a couple of derivatives. our y prime here is going to come out as a negative 2x e to the negative x squared. There's some chain rule going on there. The second derivative, we're going to have to do a product rule. So there's the first times the derivative of the second, which we already know is negative 2e to the negative x squared, plus the second, e to the negative x squared, times the derivative of the first, which is a negative 2. And if we pulled out a greatest common factor here, I definitely have a negative 2e to the negative x squared that I can pull out. That's going to leave me on this one with still a negative 2 there and an x squared plus 1. Okay. So I believe that is what we get there. We have to have a tangent line. There's certainly no place in here that causes a domain problem. No division by 0, no square roots of negative numbers, no logarithms in there anywhere. So we can set this thing equal to 0 and look for the potential places for our points of inflection. This out in front here, I can pretty much ignore. This is always negative. Okay, because the e to the negative x squared is always positive, and when we multiply by the negative 2, we're going to get that. So our focus is going to be on the negative 2x squared plus 1, which is going to happen where 1 is equal to 2x squared, or x squared is a half, or x is plus or minus root 2 over 2 when we've done our simplification. So if I'm looking on my axis here, I've got important points at root 2 over 2 and negative root 2 over 2. 0 is in between them. If I put a 0 in here, I'm going to get out of this part, I can say that when x is equal to 0, this is greater than 0. This is a positive 1 times something that's always negative. It's going to be negative. So my second derivative here is negative, and in this range in here, that means I'm going to be concave down. If I go outside of that, so I can put any number out here that I want, like if I put a 10 is out over here, then this is going to be negative 199 times a negative. So my second derivative will come out positive there, and this will be concave up, which means that this is a point of inflection. Okay. And the same thing over here, because the squared is going to give me symmetry on there. So this is also concave up because the second derivative is greater than 0 out there. So both of these are points of inflection. And the actual locations of the points of inflection, I've got a negative root 2 over 2, comma, e to the 1/2. Okay. I think when I put that in there, and then I've got another one at positive root 2 over 2, comma, e to the 1/2. So that should be my 2 points of inflection. I definitely got a concavity change, and I had tangent lines at those locations. All right, a little bit left to go here. Setting motion along a line. Okay. Actually, I'm going to, well, we'll talk about it here. The position of a particle will be modeled by the function x of t. You can see what it is there. Find the velocity and acceleration, describe the motion of the particle. Okay. Well, velocity would be the first derivative. So we can say the velocity is 6t squared minus 28t plus 22. The acceleration of the particle is the derivative of that, so that's a 12t minus 28. The velocity is quadratic, positive, open up there, so our we could figure out at 0, this is at 22, and it's opening up, so it looks like our velocity is probably, because we could figure out where the vertex of this was too, that's minus b over 2a, so 28/12. That looks very familiar to where the acceleration is going to be equal to 0, which is a number that's bigger than 0. So this looks like it's going to start slowing down. It'll slow down a little bit. The velocity will get less and less until we reach 28/12 seconds, at which point we will have a slowest velocity, and it will speed up after that beyond what is reasonable, certainly. At t equals 1 second, is the particle speeding up or is it slowing down? Well, the velocity at 1 second is 6 minus 6, 20, 28 minus 28. Okay. The velocity at 1 second is 0, so it says that it is not moving at 0, so it probably means that it had been moving in a positive direction but slowing down, and now it's moving in a negative direction, which if we look at the acceleration, because when it's asking speeding up or slowing down, we're asking about how the velocity is changing or how the speed is changing. And the acceleration at 1 second is 12 minus 28, so that is negative 16. It has a negative acceleration, so it is getting slower. Okay, the speed is changing in a negative way, and so this is a tricky question. Okay, because if it is not moving at all, but its speed is, but it has a negative acceleration, it would seem like if it is literally not moving, in the very next instant it will be moving, and I would say speeding up, because the positive and the negative, if I'm talking about speed, are irrelevant. Now, I put this in here because they used to ask a question like this on the Cornerstone final until the math teachers at the Cornerstone meeting had about 2 hours worth of argument as to what this is, or it might have been an email argument, and finally decided it'd be better if you just didn't ask that question. So hopefully they have taken that to heart and will not put that question like that on the final, because I think I could argue it in lots of different ways. Okay, over what intervals is the particle accelerating and where is it decelerating? Well, we know that the key here is at 28/12, that the acceleration is 0. This is a line with a positive slope, so it must have been negative over here and positive over here. So we would say it is decelerating between 0 and 28/12 and accelerating to the right of 28/12. Okay? Over what intervals is the particle moving left and right? Well, moving left and right, that's a question of where is its position relative to 0 increasing and where is its position relative to 0 decreasing. And so that's going to be a question for the velocity. Okay? And so we would want to factor probably that velocity equation. We can pull a 2 out of there, make that a 3t squared minus 14t plus 11. And I would say 11 times 1 and 3 times 0. I want to know where this is equal to 0. So it's like a 3t and 11 and a t and a 1. And they're both subtracting. I believe that would be how that factors. Yep. So we know that the velocity is 0 at 1 and at 11/3. And knowing that this is a parabola that opens up, that means that it would be above the x-axis over here, which is increasing because it's a positive first derivative. So if it's increasing, then it's moving right. And this would then be below, the derivative would be below the x-axis, so that's negative, f prime negative, which means it's moving to the left. And then the f prime over here would be positive again, which means it's now moving again to the right. What is the minimum velocity of the particle? The minimum speed of the particle is 0, but the minimum velocity is going to be at the vertex of that velocity equation, which we already decided was at 28/12. So it's going to be whatever the velocity is at 28/12 or 14/6 or 7/3. And so if I plugged 7/3 into my velocity equation, ran that through there, that would give me what my minimum velocity is, and hopefully that would be a negative number, okay, at that point. All right.